So every week I'll try and post an update about what I think are the most important points for the week. Sometimes it helps students to hear someone say things out loud. So these are not every single thing covered in the book, but things that I want to highlight. Still, you are responsible for reading in the textbook. So let's get started. So the first module talked about the math issues that you need to know. So I just want to review a few of the important math pieces of information. So the first is the issue of dealing with percentages. We're going to move back and forth between percentages and decimals quite a few times throughout the semester. So for example, if you had the decimal 0.217589 and you were asked to turn that into a percentage, what you would do is you would take the decimal and move it to the right 2 places, making it 21.7589%. Or if I had given you a percentage and asked you to change it back into a decimal, you would take the decimal place, the decimal point from the percentage back to the left 2 places. The policy for this class is that we will always be rounding to 2 places, no more, no less. So if we had the number that we had just gotten from the percentage calculation of 21.7589, we'd actually need to round that because there's 4 decimal places there right now. And that would be rounded to 21.76 because the number after the 5 is an 8, which makes it go up. Anything 5 or greater is going to make it go up. Anything 4 or less will make it go down. Just as a quick note about order of operations, this won't be extraordinarily important past the first few weeks, but remember the mnemonic of please excuse my dear Aunt Sally. You do anything inside parentheses first, followed by exponents, followed by multiplication and division, and then addition and subtraction. And finally, we have the summation notation, which is a character that you maybe haven't seen before, but that will pop its head up once in a while. Basically, the summation notation, which looks like this M flipped on its side, means to add up everything that comes after it. So it just wants you to sum the things that follow it. Alright, so let's talk a little bit more broadly now about what statistics are. And the good definition that I like is that statistics are a mathematical way for organizing, summarizing, and interpreting information. That's a really broad definition, so let's talk about the specific reasons why we need statistics. Why the heck is it that you have to take this course? Well, the main reason is that statistics are what allow scientists to test hypotheses. A hypothesis is an educated guess, and you could hypothesize all day long if you wanted to, but at the end of the day, as a scientist, you need to be able to test those, and you want to have some kind of a standard way to test those. So the second main reason that we need statistics is for that standardization. It helps us understand data so that when a psychologist is dealing with data and a biologist is dealing with data and a medical doctor is dealing with data, they're all speaking the same language, so it's the case that they could potentially understand one another's findings. It would be problematic for science if psychologists were speaking one number language and doctors were speaking a different number language, for example. The third reason that we need statistics is because once we are able to test our hypotheses and get some standard data output, we have to be able to interpret that data. In particular, what we want to do is draw conclusions and see if we can make any generalizations from the sample to the population. And finally, once we have made some conclusions, we need to have some sense of how certain we are that these conclusions are correct. Of course, there's always error in anything human, and statistics is no exception. The values that we learn about, especially towards the second half of the semester, will help us understand how certain we are about the conclusions that we draw. So where do we get the data that we use for statistics? Well, there's 2 different sources. You could either get data from a population or from a sample. A population would include all of the people within the group that you wanted to study. So if you were interested in knowing about BSU fans' perceptions of the blue turf, the population would include every single BSU fan that exists, not just in Boise, but outside of Boise, also in the entire world. Of course, it probably seems unreasonable to ask all of those people and collect data from all of those people. So oftentimes what we do in science is just simply take a sample, and the sample is a small subset of the people in the population that should hopefully represent the population as well as possible. So maybe the sample for us would include 1,000 BSU fans, and we'd ask them the questions. Using statistics in the long run, what we want to do is to take the solution or the answer we got from the sample and see if we could generalize that and say something more broad about the population. That's what statistics allows us to do. So Module 2 talked about the 4 kinds of data, and the 4 different kinds of data we'll deal with this semester are based on the scale of measurement that's used to record that data. So the four scales of measurement, first are nominal data. And nominal data is when you have categories that have different names. So here you basically have given a group a name and you have to assign that a number, because as you'll learn when you start using the PSPP program, the software program, you won't be able to write words into it and have it run statistics on words. You can only run statistics on numbers. So sometimes we have to give a group of people a category, a name, a number. So here the data value actually means nothing without the associated name. So for example, if we're talking about gender, perhaps I assign males a 0 and females a 1. That's completely arbitrary. I could have made males 1 and females 0, or I could have made males 9,942 and females 63. There's really no difference because the number doesn't mean anything. The number is simply a representation of the group that it stands for. So anytime you had a categorical or group variable, you probably will have nominal data. The second kind of data are ordinal data. And here what you're doing is you're having categories that are organized into an ordered sequence. So with the nominal data, it didn't matter which order males and females came in. I could have flipped them around. With ordinal data, it does matter which order they come in. The categories therefore have some implications in terms of the data having meaning, because it helps us know the direction of the difference, direction of how the variables are related to one another, but nothing about the magnitude of that difference. So for example, rankings. If you have someone who's running a race, you have a first place finisher and then a second place finisher and a third place finisher, and that rank has meaning. We know that first came before second and second came before third. Here we couldn't reorganize them. We couldn't say third, first, second, because that's not how it works. However, the difference about the issue about the magnitude comes into play is if you imagine that this is a race, like a running race, and the person who comes in first comes in 4 seconds before the second place runner, and the second place runner came in 50 seconds before the third place runner. That means the difference between first and second, and the difference between second and third would not be the same. That doesn't matter for ordinal data, however. It's just the order that counts. The third kind of data is interval data. Interval data is when you have categories that are ordered on intervals of the same size. So here, the amount between 1 and 2 and 2 and 3 really needs to be the same. One thing to note about interval data is that 0 does not have any meaning. So sometimes in the world we'll find variables where there's a 0, but 0 doesn't mean a lack of something. But because the categories are ordered and the intervals are on the same, this helps us know about the direction and the magnitude of the variable. So for example, temperature. If we have 30 degrees versus 40 degrees versus 50 degrees, those come in an order, which is important, but the difference between them is also equal. So the difference between 30 and 40 is 10, and the difference between 40 and 50 is 10. So that would make it the interval variable because they're spread out on specific So that would make it an interval variable because they're spread out equally. But when we think about 0 degrees, what does 0 degrees mean? Does it mean lack of temperature? No, it doesn't. So that means the 0 value is not meaningful. 0 means really freaking cold, but not lack of temperature. The last kind of variable is a ratio variable. Ratio data is just like interval data, but it has a meaningful 0. So the amount of space between all the intervals has to be the same. It needs to go in order, but here the 0 means lack of something. So for example, if you have a person who's 5'6" versus 6'6" versus 7'6", there's 1 foot in between those intervals, making them evenly spaced. But what about a person who's 0 foot, or something that's 0 feet long? Does that mean lack of height? And in this case, yes, it does. So that is a meaningful 0, which would make it ratio as opposed to interval data.